Hi viewers, this is before you Professor Pradeep Kumar, Department of Mathematics, University Professor, Principal MSSG College Areraj is before you. Today in this lecture I am going to give you a very important topics in mathematics of undergraduate students, convergency or divergency of a series. Friends, convergency and divergency of text in mathematics in two ways. For the convergency and divergency of a sequence, and next the convergency and divergency of a mathematical series. We will start some of the points in this lecture. We start the concept of convergency and divergency from the physics chapter optics subject. As we all of know that the rays from infinity meets at a point which is called focus, or mean to say that the rays from the infinity meeting at that point, and that meeting point is called focus, which has a high intensive point. And just reverse, if we want to understand the concept of divergency, it is just reverse to convergency, or mean to say, if from a point a rays spread out or coming out, then it goes to infinity. It is called the rays diverges from a point F. Now we come to the mathematics. We are going to discuss the convergency and divergency of a series. Friends, infinite series is an important chapter for undergraduate students. Now we will discuss, and likely to be I will finish this infinite series in a maximum 5 to 6 lecture. Today I am going to start the concept of the convergency and divergency in terms of series, which is in infinite series. Friends, if there is some points which declares whether this series is convergent or divergent. Now, if S be the sum of a series, then we find the sum to n terms. We take n terms and we got its sum to n terms, that is Sn. And next step is we take limit Sn when n tends to infinity. If this is finite, then the series is convergent, or if this limit is infinite, then series is divergent. This is the simple concept. In the beginning, we have come to cross whether a geometric series is when convergent or when divergent. We will discuss the convergency or divergency of a geometric series. Now for this, we take a geometric series whose first term is A and common ratio is R. then geometric series will be formed as A plus AR plus AR square plus so on. Now, for the test of convergency and divergency, we have to take sum to n terms. Friends, as we know, when common ratio is less than 1, then Sn is equal to A into 1 minus r to the power n, bracket closed, divided by 1 minus r. And in case when common ratio is greater than 1, then Sn is A into r to the power n minus 1 divided by r minus 1. Now we discuss some cases. Case 1, when common ratio is less than 1. In my PDF, I have written and want to clarify as when r less than 1, then Sn is equal to, that is the sum to n terms of a geometric series, Sn is equal to A 1 minus r to the power n divided by 1 minus r. And when we take limit of Sn, that is limit Sn n tends to infinity, and right hand will be equal to A by 1 minus r, and next Rn tends to 0 as r less than 1 when n tends to infinity. It means Sn is equal to Sn, limit n tends to infinity, Sn is equal to A by 1 minus r, that is finite. It means the series is convergent. Now we take case 2, when r greater than 1. In this case, the sum Sn is equal to A r to the power n minus 1 divided by r minus 1. And when we take limit n tends to infinity, Sn is equal to infinity, because Rn tends to infinity as n tends to infinity, because r common ratio is greater than 1. In case of r greater than 1, Rn tends to infinity is equal to infinity. It means that the series in case of r and common ratio greater than 1 is divergent. And case 3, when common ratio r is equal to 1, in this case, S is equal to A plus A plus A plus A plus up to infinity. It means Sn is equal to n into A, and when we take limit n tends to infinity, Sn, it is infinite. It means that when r is equal to 1, the series is divergent. In brief, a geometric series will be convergent if common ratio is less than 1, and it will be divergent if common ratio is greater than or equal to 1. This is the beginning concept of convergency and divergency of a mathematical series. Friends, we can easily see that the sum of if two convergent series is given, then its sum is also convergent, its difference is also convergent. If two series is given divergent, then its sum or difference is also divergent. Or in case of multiplication of a series with a constant number, if S be a infinite series and K is a constant term and S is convergent, then K into S is also convergent. If S is divergent, then K into S is also divergent. Friends, we have so many theorems for the convergency and divergency of series. We will discuss the further theorems like Cauchy theorem, Rabi's test, logarithmic test, auxiliary series, etc. We will discuss one by one step, and I will invite all of you for discussion, for discuss with me, and you should give your problem before me so that I could solve your problem easily and you could get benefit from this lecture. Thank you very much. Thank you.